what I'm trying to do is that take you step by step towards LLMs. Where I told you, my intention is that at the end of the show, you should be able to create your own LLM. And uh, whether you do it as a business or not, that's a different issue. But you can definitely solve a lot of problems for your organization or for yourself. Like, what do you call? I was discussing in the last class also that LLMs are not really a general purpose solution for organizations because, say, for example, you have your HR policies or you have your even if you have your tech support guidelines, which many company are going up to using co-pilots, etc. But you notice very soon, in another 5-6 weeks, that they're not a very good solution to give co-pilots to people, and it is unnecessarily expensive and doesn't really solve their core problem. So there, in those circumstances, if you can make a dedicated model, it will not only reduce the cost by more than 20-30 times, it will also give a much more focused solution to your engineers, which can be beneficial. Yes, Aditi.
Partha, so right now also there are many like kind of LLM only that organizations are using, but they are actually they are actually pointing to other LLMs, right? So even if like my system is called Maya in my organization, but I'm sure that they have not built it from scratch. They are referring to some other LLM, and if they are not updating it on a regular basis, it's better to use the actual or the original LLM rather than using Maya, for example. So that kind of issues also some organizations are facing, and will what you are sharing today will help solve that problem?
Yes, of course. See, there are some organizations inherently they cannot use a public domain solution. Like, for example, quite some time back, I had a when I was studying in IIT Kanpur regarding cybersecurity. There was a colonel in our batch. He is currently in Murshidabad. He's posted there and is working on IoT devices and all that kind of stuff. This fellow approached me and said that, see, I want to have a LLM in the army, but my problem is that I cannot go to any of these OpenAI or Gemini or anything. The Gemini was not very popular at that time. OpenAI definitely was popular. ChatGPT. I cannot go to them because we cannot upload any of our documents in the public cloud, and even if it is secure for us, we cannot afford to take the risk of exposing any of our documents. So for them, for situations like this where the security and the confidentiality is very important, you cannot go to a public domain solution like using a LLM like ChatGPT or Gemini or something, or Claude or whatever that is. So for those people, it is absolutely mandatory that you use a dedicated system for yourself, and you will notice that if you understand the concepts very well, then it is developing a LLM doesn't take much time. Okay. It doesn't take much time, and you have the complete control of the technology, like how you want to manipulate it, what it should generate, what it should output, everything. You have total control over that. So and but this risk of exposure is not only in premium organizations like Indian Army or something like that. It is there with any organization. Like, take for example, if you have a bank, let's say any bank, whether it's State Bank of India or whether it is JP Morgan or whatever. Now, if they use LLM directly from an open source, like even like I also told you, I use ChatGPT, and my ChatGPT, I have got a private space where all my documents are kept. Okay, I have purchased that service, so I'm not really on the public cloud. I'm on a private space when I'm using ChatGPT. Even then, I have the risk. Like, supposing, for example, I may not be a high profile guy, but no one will attack me. But if there was a high profile guy, there are people who are constantly probing and trying to figure out whether they can get hang of my data. So, and if there is a compromise, if there is a breach anywhere, then you see there's a huge risk to that organization, like a bank or any other organization for that matter. So for these reasons, why it is very imperative that you should have your dedicated LLM. Now the problem is that in today's, at least in India, It is not only in India, even in JP Morgan is not really Indian company, it's an American company. So the know-how regarding how to build LLM does not exist. And this is actually a very big problem because people are taking the easy route where they are just about using AI, whatever tools are available, and making the life easy and reducing people and so showing that I have reduced cost by so much. That is not the actual way. If you are actually you want to use AI, then you got to understand the nuances and build tools around AI which can be actually beneficial in the long run for your organization. So that is the effort. Now, this is what do you call? This is a thought which I'm putting in your head. You think about it and see the merits and demerits of this, and then you can decide. And most importantly, like people do not venture into their own development simply because they fear that it will cost very heavily and whether they will get a return on that investment or not. But you notice very soon that if you understand the concepts very well, then developing such a tool is not very expensive. So that's where we are. Okay, I think we have waited for 10 minutes. I don't think anyone else will join. So let's proceed. So what we have done so far is that I initially showed you. Okay, we went through tokenization. We understood. We have not really taken full advantage of all the different tokenization techniques, but we will do that from next class onwards. You'll see that we will start taking advantage of the tokenization techniques. But anyway, after tokenization, we first went through some trivial mechanisms like we thought of one-hot encoding, and then we did TF-IDF. TF-IDF basically what we found was that we were able to find some semantic relationships on a global this thing, but it really does not understand anything regarding the language. It is just about counting, and it is saying which counts are showing a better proximity, and though geometrically it gives a solution, but that's about it. Then, most importantly, in the last two classes, we went through this word-to-vec class of solutions, where instead of looking globally at the entire corpus, what we did was that we looked at the corpus in a very local level, where we said, okay, fine, for a particular word, tell me what is the context, what are the words around this particular word. We tried to predict that. Similarly, for the words around a particular word, we try to predict what is the word in between. So using these two techniques, which are local techniques, we were able to see that the machine is able to learn the language quite effectively, right? But then in this local approach, what is happening is that it is ignoring any kind of what do you call macroscopic corpus statistics. It is not able to look beyond the local windows which we are providing to him. So it may miss out some important nuances while it is doing that. So now today we are moving one step forward, where you going to use a global context. We look at the complete global what do you call corpus as a single unit, and try and see if we can build a technique by which we are able to make the machine understand on a global level. So we are going to discuss GloVe today. GloVe basically stands for global vectors. So we are still in the business right now of creating embeddings, and like I'm telling you, embeddings is the first step towards building LLM, because LLM is nothing but a very deep neural network, and we will see how deep and how shallow we can make it. But then the first thing which enters into the LLM is the embeddings, and only from the embeddings will I start developing my neural network, which will actually transform into something which will continuously keep on generating outputs for me. So now, so today's effort is that if we can use the global context and create embeddings, and those embeddings, if they can give meaning to the words which we are dealing with in our system. So, any questions so far? Anything which you are slightly having doubts, or anything which is in your mind?
Not much, sir. One thing, I am joining. This is first session I'm joining. Before that, whatever sessions happened, I didn't. Is there any recorded sessions are there so that I can?
Yeah. I have the recorded sessions. Do you want? Okay. Okay, I will give you the recorded sessions. It will be beneficial if you go through the recorded sessions, and I will share today's recordings also, and I will do that. I'll not stop right now to share the recordings.
No. Just I'm checking because you can share it later.
I will share it before the end of the class. I will share it.
Oh, thank you.
One more feedback, sir. In your recordings, all the participants' window are blocking little bit of screen on the right hand side. I don't know if you can record the main screen, and today I don't see it. I hope today will be okay.
No, I minimized it. I did not know this particular feature of Zoom, so today I minimized it, so you will not see that on the screen.
Okay, thank you so much. Yeah.
Okay, so let's move forward. So the strategy will be like this. I discussed the main things on this slideshow, though I'm giving you this PowerPoint presentation, and you can keep it for reference in the later, because it summarizes the whole stuff. But the core discussion I will hold on the Jupyter notebook, where I have worked on the solution and given a step-by-step treatment to how this entire thing unfolds. So okay, so let's move to the Jupyter notebook, and I will show you these concepts, how they are unfolding. Okay, so let me move over there. So now what we will do is today we will understand, like last time also, last two classes, we are going to make a neural network, and in the neural network we're going to see how to make the global embeddings. So what we will do is, first we will take a single forward pass of the neural network, understand how we are setting up the neural network, and then we will go through the complete neural network, where we'll do the forward pass, backward pass, until the learning is complete and we get the embeddings. And then lastly, what we will do is that we will apply these embeddings. We will create this technique. We will use this technique to create the embeddings for the Jane Austen's books, and check whether the machine is able to learn the language of the language as presented through the Jane Austen's books. So we'll do that. And lastly, like I wrote in the poster also, we will create a next word predictor. Basically, it's not a next word predictor. We will make a predictor so that I can give a starting point, and it can try to take the sentence forward. So we'll see how to do that. Okay, so let's get started. So right now I'm in the forward pass, so I will tell you the purposes of every step so that it is easy to understand. So I take a vocabulary, I take a sentence. Normally, you know that my corpus will contain a lot of sentences, but for simplicity, I have taken just one sentence. This is the sentence here: I like orange juice and eat eggs daily. The same thing we used in CBOW and skipgram also. And I take out the vocabulary from this. So I know that this sentence, I get these tokens. And right now I'm doing word tokenization. I'm not going further down. You know, there are advanced tokenization techniques, which I'm not able to take advantage of right now, because GloVe would not support that. So by the way, this GloVe algorithm was created by Stanford University. This is just for historical information. Now, so from these tokens I get right now, every word is basically a token, and so the vocabulary becomes this much, and the vocabulary size is 8. There are 8 words, and I want to make embeddings of the size 3. You know that I can control this. So right now, let's say that we want to make embeddings of size 3. If embedding of size 3, you would understand, like for people like Janardhan, just to make you understand that I have this word. Let's say I have the word like, and I want to represent it in the vector space. So I've taken 3 because on the 3-dimensional plane, I can represent the whole stuff. And basically what I'm trying to do is that if I can make a representation of this word using 3 elements, 1, 2, and 3, so then I can treat them as x coordinate, y coordinate, and z coordinate, and plant it somewhere on the vector space. So let's say here. So this is got like this. It has got something on the x-axis, y-axis, and z-axis. So so this if I can do that, then once I'm able to plant it on a coordinate system, then what happens is that I can plant other words also and check whether these words they have similar meaning or they have different meanings, And if it is able to distinguish that the similar words are brought together and the different words are pushed apart, then we have taught the machine a particular a language by which it is able to distinguish between what comes together, what goes far away, and things like that. Right. So that is the whole effort. So right now I want to make a word into a representation that's a 0.2 and 1.5 and minus 0.4. So if I can represent a word like this becomes a vector which I can use for many different things. Like I can try to use it for. We have seen applications like if I say if I ask the computer what if Paris is to France, then what is New Delhi? New Delhi is to which country? So it can answer such questions, right? Or so we have seen that these such applications in the previous classes. Okay, so anyway, coming back to the point, we are trying to make an embedding of size 3. So we will proceed forward. Now the biggest thing in GloVe is that what I do is that I told you at the very beginning we will take the global context. So global context means it's very important to understand in GloVe that we will make something known as the co-occurrence matrix. I will show you what a co-occurrence matrix is. And this co-occurrence matrix is a very heavy part of the algorithm, and we do it only once. We do it right in the very beginning, and then the whole process becomes very easy from there onwards. So co-occurrence matrix, let me build it and then I will explain what exactly it is. So here you see that my sentence was I like orange juice and eat eggs daily. So the co-occurrence matrix says that I and I, the distance between them is 0, right? But I and like, the distance between them is 1. Okay, because there is one word difference between the two. And then when it comes to I and orange, it becomes 1 by 2 because the distance between them is 2 distance. So 1 divided by 2 becomes 0.5. And then anything, right now my window size is supposing I take the window size of 2, which I have taken here. So anything outside the window size of 2, I say there is no co-occurrence between these two words. So what I'm trying to teach the machine right now is that try to learn the fact that the words I and like, they are appearing they tend to appear together with a little bit lesser possibility. I and orange appear together, though orange is slightly far away, and so and so. So I make this co-occurrence matrix, and so this gives me exactly the distances between every word. And you notice that there's a lot of zeros here. So this is also a sparse matrix. So we'll see how to deal with this sparse matrix. But right now, I have made the co-occurrence matrix. Any questions so far? Understanding this is very vital.
One quick question, sir. So in the co-occurrence matrix, if I notice, the distance between the word and itself is 0, and to the right is 1 and the left is 0.5. Isn't it creating something like the window?
No, this is the window, right? Window is of size 2, right?
Okay.
So this is my sentence.
It is creating a pattern like the sliding window, right? Like, around it.
Yeah, it's creating a sliding window around each word. So if you take the word like, for example, like is with itself it has got a distance of 0, but with orange it's got a distance of 1, right? And like has got a distance of 2 with juice. So 1 by 2 becomes 0.5. And this is how I am calculating, and this is how I'm assigning distance to each of the words in the corpus right now.
Okay. So is it calculating the letter common, or like how is it doing? It has got
no what do you call understanding of the letters. It is just that this is a token and this is a token. What is the distance between these two tokens? What is inside the token? He doesn't know. He has no idea.
Okay.
Okay.
I got it.
Yes, Aditi.
So, Partha, so outside of the window size, everything will remain 0. We will not assign any kind of a value to that, right?
Yeah, that is the strategy. See, I can change my strategy, right? But that is the strategy. Anything outside the window, I consider the distance to be 0 because there is no proximity between those two words.
Okay. And this will be done for the entire corpus. This is just the example where we are seeing, but when we do it for like the entire big data set, that also is done in the similar manner.
In the same manner. In the same manner.
Okay.
Okay. Now, right now, my entire corpus is just this one sentence. Right. That's why it looks like this. It is easy for explanation. But when you take an entire corpus, you take an entire book, or you take an entire set of 5-6 books, you will do the same thing in across the entire book, and you will generate this co-occurrence matrix. Okay.
Sure. Thanks, Parth. Yeah.
Okay. So once I get the co-occurrence matrix, now these numbers are important. According to word GloVe, these numbers, they're represented by the symbol xij. xij. Okay. Now xij means what? I is one word, that is, let's say like is one word, so I becomes like, and j becomes its context, that is orange in this case. Okay. So I can say that xij for x, I can say like and orange. How much is this? So like and orange is 1, right? 1.0.
It's 1.0.
This is the place. Okay. So now we get this value. Now this is important. Just remember this. I will come back to this as we proceed forward. Okay. Now what we do is that right now for the forward pass, we will do this multiple number of times. Actually, in neural network, I consider two words. I consider the target word as orange, and I consider the context as juice. So I have to take them in pair. So if I take them in pair, I can calculate the xij just like I did in manually with you guys, and I can show the co-occurrence. So it looks like this. So the target words index is 2, the context word index is 3, and the co-occurrence is 1.0. You can see that this is orange, and this is juice. So they are next to each other. So the co-occurrence xij is 1.0, right? Okay. Now what I do is that, like that I will show the neural network also. In the neural network, I will have the weights. So I randomly initialize the weight, just like we did for CBOW and for skipgram. I am doing it completely randomly because I do not know. I have to train the neural network to understand what these values are, and these are the weights which are you understand from the skipgram and CBOW discussion. This is actually going to give me the embedding. So I do not know what the embeddings are, so I completely randomly initialize them. And apart from the weights, I'm also initializing a bias. So there is a bias for the network. So I just initialize them. I get some values. So I get some random values like this. Let me just clean the screen so that it's easy to understand. Okay. So these are random weights. So ultimately, you'll notice that whatever values I get for these W matrix, W and W tilde matrix, this will form my embeddings. So right now, since I do not know, I'm initializing them to some random value. Once I've done that, what I do is that I make a GloVe weight. Now here I'm going to use a formula saying that I'm going to calculate x by x max. X max is basically, let me take it to the presentation. Okay. X max is, I set a ceiling. Okay. I set an upper limit. I say that the upper limit is 100. And x, like I showed you, I can calculate the co-occurrence and I can store that. So if I do a division between x and x max, what can happen is that x can be greater than x max, or x can be less than x max. So for first ground rule is that I say that if it is x is equal to 0, then this x by x max, I consider that to be 0. That is number one. And then if I have a rare word, if a word is rare, then the co-occurrence matrix will show that it is having a x which is much less than x max. So in that case, I can calculate x by x max and I will take that value. But if a word is appearing very frequently, like, the words like the, and etc., then x max, then x will explode. And in that case, what I will do is that I'll put a ceiling that you can explode in terms of number of times you're occurring, but your maximum value can be only 100. So that is what I'm doing here. Okay. So this is the whole function which I have written here. So you notice that I compute the xij and I try and check. I put a value for x max, and now as the occurrence of the word increases, I will give it an extra weight in terms of a term called alpha. So if I put alpha is equal to 1, you notice, you see the formula here. I am raising x by x max to the power of alpha. So if alpha is equal to 1, it basically remains x by x max. So the growth will be linear. So if I consider this graph here, so if I put alpha is equal to 1, the growth will be linear. So I may not be interested in that. So instead of that, I set it to a value like 0.75. So the growth is slightly actuated, and it ultimately, I will say, it cap it at x max, which I have taken as 100 here. Okay. So this will give me the ability to control how to represent rare words and how to represent common words. So I do that. So I get some values, and now what I do is that I just look at my I take out the w vector and the w tilde vector for my individual words. So I do that for my target word first. So target word and context word. So for wi for orange is right now this vector, and w tilde for the context word is this vector, and the bias terms are like this. This is nothing like I showed you last time also. This is basically by in the previous time, in the previous skipgram and CBAO, we use the one-hot encoding to extract this. Right now, we're not using one-hot encoding because I have got the same I've got just representation of every word in a matrix itself. So I can just go to the index and I can pick out this element and I can show it as belonging to this element. So if you see the orange here, it is 0.015 and so and so. So if you see the value here, see, it is the same vector what it is showing me. Similarly, for juice, it is 0.01 minus 0.0105. So if you see the W tilde matrix of juice, this is the vector which I get. Okay, so once I have these two vectors, what I will do is that I will take a dot product of Wi and W tilde j, and that will give me a dot product. That is a single value. And now what I do is that I make a calculation of something. Why I'm doing this is because I want to ultimately arrive at a loss function, right? So I calculate Wi tilde, which I have done in the dot product, and I add Bi, the bias terms of Vi and B tilde j, and this becomes my prediction. And this prediction has to be as close as possible. I told you xij, I told you to remember. Now what I do is that I take the log of xij, and I have to see that this value, the log of xij, is as close to the prediction or not. So if I make a function like prediction minus log xij, and I have to minimize that effectively becomes my loss function, which I can minimize. Do you guys follow me? Yes or no?
I'm little lost, Partha.
Yeah. The thing is that I make a prediction. The prediction is what? Prediction is Wi into W tilde j plus bias plus the bias terms. So this is my prediction, right? and I say that this prediction has to be as close as possible to the log of xij. You know what is xij? That is a co-occurrence, right? For a particular word, like here I is orange and j is juice. So I what do you call? You could calculate. Right now, I've taken all the wi's at random. So from the wi's, I can pick out the wi for orange, and I can pick out the w tilde j for juice, and I can multiply them. This I have shown you here, and I get a number. This number I can add to the bias terms. The bias terms right now I have taken at random, and these are the bias terms. Now this becomes my prediction. Now this prediction, I'm saying that this prediction has to be as close as possible to log of xij, log of the co-occurrence, right? So if it has to be as close as possible, then what I can do is that this term, that is a prediction, minus log of xij, if I take that value, if I minimize that value, then I have a loss function which I can minimize. Does it make sense? Like what is linear regression? We took the mean square error and we tried to minimize the mean square error, right?
Correct.
So here I'm establishing a loss function where I'm saying that whatever I predict, that prediction has to be as close as possible to log of the co-occurrence. And if I can minimize that, then I will get my what you call neural network with the optimum values. Yeah.
So how did I come up with that formula? Like, how do I know that the wi times w till j plus bi plus b till j, when I minimize that with the log of xij, will be close to that? How did I get to the left hand side? That's what my question is.
Okay. Now left hand side, how did I get is that I have my co-occurrences, right?
Yes.
I have my co-occurrences. Now, co-occurrences. So I have a what you call pinpoint co-occurrence for every pair. Like orange and like, I have a pinpoint co-occurrence. So orange and juice, I have a pinpoint co-occurrence. So now instead of, I could have said that, okay, fine. What do you call? What I'm saying is that I can find the log of this particular value. And that is something which I have found out through engineering, that if I find the log of this value, that will represent how close or how far the words are to each other.
Correct. If the logarithm is 0, then it is close, right? Because log of 1 is 0.
Then it is absolutely zero. What do you call, next to each other.
Okay.
Okay. So right now, by doing this, by taking these pairs of calculations like wi, wj, and all that, I'm able to make a prediction in terms of what should be the proximity of the two words, and I know that log of the xij, it is an indicator of how close the words are to each other. So I'm trying to find out whether these two are close to each other or not. Now this is basically the formulation of the algorithm. Okay, this is basically the formulation of the algorithm where I have to minimize the gap between this prediction and the log of xij. Okay, that making sense?
Yeah.
Okay. So let's check it out. So right now you see that my prediction is giving some value, and the log of xij is 0. So there is some difference between the prediction and the log xij. If I calculate the difference, now this difference is what I have to minimize as much as possible to get the what do you call, proper neural network, what do you call, ultimate calculations for the neural network. So this difference becomes my loss. So I calculate my loss, and after I calculate my loss, my forward pass is over. So if I try to visualize my neural network, it looks like this. So you started with two words. One was a target word, that was orange in our case, and a context word, that was juice. You randomly picked up a wi for that, and a bias term for that, and for this you picked up on a wj and a bias term. This is right now done at random. Then you found the dot product of this w I and wj. So you got the dot product. Then your prediction value was this dot product plus bi plus bj. This is the prediction. And outside you took the log of the xij and you created a residual in terms of this prediction minus the log of xij. You got some value, and this value basically is this residual. I because this can be positive, negative, so I square it and I multiply it with this fxij, which is nothing but the co-occurrence. So that becomes my loss function. And so what I have to do is that I have to minimize my loss function. So this is the forward pass. Now what I have to do is that I have to utilize this forward pass and then go backwards and optimize the wi, wj, bi, bj, so that when I come back next time, this loss will be even lesser, and ultimately the loss should disappear when I get the fully optimized neural network. Does it make sense? Yes or no? If it is not clear, you can tell me. I will try once again.
Partha, I have one question, but for that I will go back to my classes of neural network.
Yeah.
Yeah.
Okay. Let's move forward. Let me see if I can clarify a doubt when I train the complete neural network. Okay. Now I will train the complete neural network, having established how I will do that. So let's see this, and let me see if we can make things more easier. I just initialize this. It takes a little time to connect to the Python environment. Okay. So just like last time, I built my vocabulary. I am making embeddings of size 3 and my vocabulary is of size 8. So I built my co-occurrence matrix. This is clear by now, I hope. So after now you see that in actual terms, what I will do is that I will extract all the training pairs, like all the combinations, like in a window of 2, right? So I like and I orange. So these are in the window of 2, and I found out the what do you call xij for each of them. So all combinations, whatever is possible, I take out. This becomes my training pair, right?
Okay. Yeah.
This is clear.
Yes.
Okay. After I make my training pairs, at random I take out the values of wi, wj, bi, bj. This is also very simple. Right now I'm initializing them to some weights. I do not know. My objective is to find these weights only, but I do not know what they are, so I'm initializing them at random. This is clear?
Okay. Yes, this is fine.
Okay. After I do that, like I told you, I find the GloVe weights, and I'm basically setting x max is equal to 100, so that common words do not overcrowd my algorithm, and there is a growth between as the word becomes more popular, that is given by the term alpha. So I can control these values. So depending on the corpus, I will control these values. Anyway, these are my hyperparameters which I have done now. Now what I do is that I define my forward pass. Forward pass I already showed you in the previous section. I take my wi, wij to find the dot product, find the prediction using dot product plus bi plus bj, and I calculate log of xij, and I take a difference between prediction and what do you call log of xij, and that becomes my loss function, and I'll try to optimize my loss function. So this is my forward pass. Okay, so I do this. Now what I do is that this is just a demonstration of the calculations. So you see that I started with the two words orange and juice. I got a xij of 1.0. There is a co-occurrences, they're next to each other. So at random I got wi, at random I got wj, at random I got bi, I got bj. I calculate the dot product between wi, wj, and the prediction is basically dot product plus bi plus bj. I get my prediction. Log of xij is log of 1 in this particular case, because xij is 1, that is 0. I have to ensure that this prediction and this log, they are as close to each other as possible. So my loss at this point of time is this much, right? So far clear?
Yes.
Okay.
Yes.
Right. Now what I do is that I define my backpropagation. Backpropagation, what I will do is that I have to minimize my loss. And how do we minimize the loss? We take the what do you call partial differential, and we check, we adjust the weights according to the partial differential. Just go back to your neural network classes and this will become clear. So I take the partial differential and I try to adjust the weights based on the partial differential. And once I do that, so that partial differential, what we take is basically the gradient. So you're seeing that I am taking the partial differentials of along according to Wi and according to Wj and according to Bi and according to Bj. Then I attach a learning rate to that. Learning rate basically says how I should keep on learning, and I adjust each of the values. That is, this becomes Wi is equal to Wi minus learning rate into the partial differential with Wi. Same thing, I do that and I return the new weights. After I get the new weights, what I will do is that again I will perform the forward pass, and after performing the forward pass, again I will check my loss, and I will continue this forward pass, backward pass till the point of time I am satisfied that the loss is absolutely minimized. Right? So that is my neural network. So I will show you a backward pass also once. So before I started, my weights and biases were of these values. So after updating, you can notice that there will be some changes, not too much maybe, but there is some changes, right? If you understand that it doesn't happen to change all of a sudden, because learning rate will control how much to change, but there is some change. So if I continue this process, ultimately I will get the most optimized values of Wi, Wj, which is actually my embeddings. Okay, so now I compute the loss over pairs. So I am able to compute the loss. Okay, now having established a neural network, I will do the training of this neural network. Now you notice here that initially there was a loss of 0.004, and it gradually is reducing as the number of epochs are increasing. If I plot this, it will become clear to you that after certain epochs, the loss settles down and it is very minimal, right? 0.0026 and all this kind of stuff. So at this stage, I can say that the neural network has learned the pattern. And if it has learned the pattern, what should it give me?
The embeddings.
Embeddings. What are those embeddings coming from?
Pair of words?
No. W and W tilde, right?
Yeah.
Yeah. Yep.
Yeah. So I get my values of W and W tilde at the end of the training. Now you notice that these values are much different from the initial values which I started with. So I can show you the initial values. Just take a look at one or two values, and where is that initial values? Yeah. So this is the initial value. Take a look at your first one. So this was randomly I assigned 0.004, and now after learning, after it has learned, so this has become 0.008, right? So it has learned, and so ultimately I have got this matrices W and W tilde. So in GloVe, what is the strategy is that we sum up W and W tilde to get the ultimate embeddings for the individual words. So that is what I'm doing here. So I'm basically summing up W and W tilde, and that gives me the final embeddings. Okay. The important thing is that, do you notice that I have a strategy to get the embeddings for the words, and I'm using a global context? Is that part of the thing clear to all of you?
And one question, in the co-occurrence matrix, instead of doing this 1.10, even if I have a random number, I will still get a final embedding, right? So that is what I tend.
But whatever be your strategy, you can do that. You can check it out. But the thing is that those numbers should keep on decreasing based on the distance as they grow, right? If you put a random number, then it will not be correct, because random number will not show the distance. It has to understand that the words next to each other are actually neighbors. That understanding has to be given very clearly.
Okay. Yeah, I understood.
Okay. So now if I take the Janardhan, are you able to follow? Is he there or has he left?
Yes. But little bit going up, but I'll just trying to get.
Yeah, you go through the previous recordings. I think you'll get it.
Yeah. That's why I'm not interrupting.
Yeah. So now you see here, after I get the embeddings, if I plant the embeddings, there seem to be some pattern it has learned, right? based on this particular one sentence, it sees that I eat happens to be close to each other in this particular corpus, or juice is close, the orange and like is close, and so it is this is a very small corpus, so but it has learned some patterns within the data, right? So if I evaluate one thing, if you orange and juice, you notice that its prediction is very close to 0.0, that is the log loss, and the residual is very and the loss is very minimal. So even with a small corpus like this is able to find patterns. So if I do it for across all the different words I have in my corpus, notice that the loss is actually very minimal, so the neural network has learned quite effectively. Okay, this may not impress you too much, so what I will do is that I will take a complete corpus now. This is the corpus of Jane Austen. So I use Jane Austen's corpus and I check whether I can generate meaning within words or not. So I am right now I am not going to be building the co-occurrence matrix and all that. Instead, what I'm doing is that I am taking the the model which has already been created, and this has got a huge amount of data. GloVe requires huge amount of data. That is one of the problems also. It has got, based on huge amount of data, it has made this particular embeddings, and I will just use this embeddings and check whether the machine is able to make meaning within the words and the language which I'm trying to learn with him. Okay, so let's check the data first. Takes a little while because it's very huge. Oh, it will take some time. Can you anticipate what can be a problem with GloVe? Anyone? Can you try and anticipate what can be a problem which we will have with GloVe? Anyone? Think about it. I will anyway tell you at the end of the class. What can be a problem? Okay, so now I have got the Jane Austen's data, and it has got a huge vocabulary of 4 million. Now, what I do is that I try to find the neighbors of these words that is there in Jane Austen's book. There is these names and these words, and let's see. I find the 10 most nearest neighbors. So now you notice that it is saying that to Elizabeth, the word Margaret, Mary, Catherine. Do you think they are actually neighbors, because they are all names of people, right? Has the grouping been happened properly? What do you think?
I think no.
What?
Neighbors, yeah.
These are all names of people,
Names.
right?
Yeah.
So they are flocking together. So do you think the machine is able to understand the language that these are names? I didn't tell him anything regarding whether they are names or whatever. I just told them they are words. But he has found intrinsically the meaning that these words could be the names of people. He doesn't know whether they're names or not, but he says they are close words to each other. Similarly, you see these are also names of people, and he says that they are close to each other. Okay, again, Emma is also a name, so it finds. Now, okay, let's look at this. So, for love, it says that these words, passion, mind, life, do you think they are related?
Yes.
Yeah, generally they occur together. Yeah.
Okay. Similarly, marriage. Look at the words marriages. Now, I'm giving you a clue. You see that the word marriages is seen as close to marriage, but what do you call? They are basically essentially the same word, right? Or birth, marry. So it is. If I look at the presentation on a two-dimensional graph, I will show you. If I look at this in a two-dimensional graph, where is it? Plot it. Now look at these word clusters. Like China, countries, states, these are together, national, state, these are together, right? And if you look at things like him, his, her, she, these are together. So it is able to understand the language to a fairly good extent. Don't you think so?
Yes, Partha. Also for the days Monday, Tuesday, Sunday, I can see in the same cluster as well. Yeah.
Okay. So you notice that using this technique of making embeddings using GloVe, I'm able to teach the machine the language quite effectively. Correct?
Yes.
But important point to notice is that he doesn't understand the meaning of any words. He only knows there is some proximity between them. That's about it. Nothing more, nothing less. Right? Okay.
Correct.
Okay. Now that he's understood the words, I can do a little bit more. I just took one more step here. That is, I take some focused words, which is definitely occurs in Jane Austen. And if I take these focused words, you notice that you can see the pattern quite evidently. Like you see here, all these words, they're definitely together, right? Father, brother, sister, and all kind of stuff. Friends, and these are some verbs. So these are together and things like that. So okay, now that we understand that it is able to understand the language to a fairly good extent, now I will utilize this facility or utilize this knowledge of the machine, and I will try to create a sentence completer. That is, let him try to make a sentence out of whatever I give him as a starting point. Let's see if he can do that. Okay. So if he can complete a sentence, that means he will understand how to write in my language, right? Don't you think so? Is that progress?
Yes.
Okay. I take Gutenberg, and from this I take I right now I'm taking the Genesis. Genesis is basically all about Bible and all this kind of stuff. So from that language, whether he can make out how to complete sentences. So I do some cleaning up. So I remove. So right now I have. Then after cleaning up, I have this kind of text, the King James Bible, Old Testament, etc., and all kind of stuff. And then I save the output. Okay. Now here is where the problem starts. I am. It's got a very fairly huge vocabulary because this is huge. There are more than 4.3 million characters in this, and out of that, I cannot process this on a machine as small as mine. Though this is on Google Colab, but Google Colab also got limitations in terms of resources it is giving me. So out of this, I take out a vocabulary of 10,000. Okay, that is the only restriction what I'm placing right now, which will cause some problems. But if I do not have this restriction, then it will behave much better. Anyway, I put this restriction. After putting this restriction, what I do is that I find the tokens, and I use up to 50,000 tokens. This is another restriction which I am putting. This will also cause a problem, but if you have a bigger machine, you can remove these restrictions and then check whether it works or not. Okay. Now you notice that I'm using a sequence length of 20. That is, my window size is 20. So I'm spanning 20 words in either side of the words, and that's how I am going to make my learning pattern. So my X is 50,000 by 20, and Y is 50,000. I already have my embeddings from which I have downloaded. So I will just use the embeddings which I have downloaded, and the embedding size is as per the model. Let me see how it is the embedding size. So let him extract that. Okay. The embedding dimension is 100. So you understand that it will make 100 element vector for each word. So now I just check this, the embedding matrix. So there are words I have got is 7129, and now this is a problem. See here, there are 2000, nearly 3000 words. It doesn't find in the in my vocabulary which I have given him right now. Now this is the problem. I was asking you what can be the problem with gloves. Now this is the problem, that if I don't have a word in my vocabulary, then the glove is totally lost at that point of time, right? So this is an area where we have to improve, where glove has got a severe limitation. Okay, right now what it does is that if it doesn't find a word in its vocabulary, it will just mark that word as out of vocabulary.
Okay. Isn't that the same thing with the other models too, sir? Like, when we are doing either the SIBO or skipgram,
It's
like,
same,
if
they have the
the
same
word
problem.
is corpus.
They have the same problem, that if the word is not in the vocabulary, they will just say out of vocabulary. They do not know how to treat that. That's a major problem with these models that we're discussing right now. Next week, we'll discuss the fast text model and we will solve this problem. Okay. So I train my neural network. Now these trainings take a lot of resources. Right now I'm training. Yes, Aditi.
Partha, I have a little basic question. So, when we are training a model on that database itself, from that corpus, how can it not find certain words? Because it is coming from the same corpus, right?
No, the thing is that purpose is not that I'm using a corpus. But what I did was that I took the embeddings which is there globally, and I reduced the number of what do you call
Right.
I reduce the vocabulary to a certain size, right? I think
Okay. Yeah,
that is why
okay, got
words
it.
are not available.
And even if that can be true, if we train it on some other corpus and use it with some
Elsewhere.
other kind of purposes.
Yes.
Okay. Yeah. All right. Thanks.
Okay. Now notice here I'm using a GPU here. That means this is quite expensive to train. Okay. So this is, as a manager, you should be careful that this is not a very cheap exercise to get this kind of things done. It requires reasonable amount of resources. Resources means money. Okay. Okay. So if I plot my loss, so I have effectively trained it. So these are training loss and value. Now let's take some words, and right now we're using Genesis, so I will use these words and check whether I can. Now what I've done is that purposefully. So if the word is very common, I'm giving it a penalty, and what do you call and another thing also I will show you, which I have done, that is, if the word is out of vocabulary, I'm giving it a penalty. I'm trying to suppress that. That is not the right way, but I'm doing it just for demonstration. But in the real scenario, what this will do is that it will cause a problem for you, saying that this is out of vocabulary. Now see here, I gave him a sentence in the beginning, and it tried to complete the sentence. Okay. It is doing something, right? It is finding different words to complete the sentence, but though it is right now making some prediction of what should be the remaining part of the sentence, but it doesn't know grammar, it doesn't anything. That is why it is what you call, seems like a nonsensical output, but it is not really nonsensical. It is applying some logic and doing it, but it doesn't understand many things, like it doesn't understand grammar, it doesn't understand anything about what do you call tense and all this kind of stuff. That is why, but he's able to predict and make sentences. At least you're impressed with that?
Yes.
Yes.
Right? You can try. Do you want to try? Yeah.
Sorry, Partha, I have a question that how is it determining the order of the words that it is predicting?
Okay, see, actually it is not determining that. What it is doing is that, see, I have two functions. Now notice this very carefully. My basic function is that predict the next word. Okay. This is my basic function. I'm basically trying to predict the next word. So every time I'm predicting only one word. Okay. After predicting one word, I put this function inside this generate text, and here what I'm doing is that I am repeatedly calling this function. After it predicts one word, I attach that one word to the seed, and I continue this process. So it looks like it is predicting a what do you call sentence, but actually it is predicting one word at a time.
Right. So the next word is dependent on the word it has already predicted before. Okay.
Yes. Right.
Sorry, Partha, but if it predicts the first word wrong, it means that if we are not able to train it properly, and if it predicts the first word wrong, maybe the other words will also be impacted.
Of course. Okay. Now tell me, what are the limitations, or from your knowledge, you tell me what all could be done so that we can make this situation much better. Just guess what could be done. I know you have an answer. That's why I'm asking this question. Do you remember something we discussed during neural networks? We have a kind of neural network called RNNs, and these have got variations like LSTM, GRU. Do you remember? Yes or no? No.
Not
What are RNNs?
Recurring neural network, but I am not able to get the answer.
Yeah, recurrent neural networks. Recurrent neural networks are, why do we make them? Because they can remember the sequences, right? So wherever there is a sequence, we use recurrent neural networks. So right now you see that I'm basically predicting based on probabilities, but then it has got no memory of what is the previous words and things like that. So if I can replace this, if I can augment this with a form of recurrent neural network, either of these forms, then what it will do is that it will remember what are the previous words which I have fed to him, and based on the previous word what I have fed to him, he will be able to do a better thing regarding how to predict the next word. Don't you think that is possible? Yes or no? Do you require time to think?
Yes, Partha, sorry, I'm lost.
See, if it is able to remember my sentence, like I say that I am very. Okay. Right now, what it is doing is that it's taking this as a seed, and it is saying that, okay, based on these neighbors, I think the next word should be something. Based on this neighborhood, just on the co-occurrence matrix, it is predicting. Correct? That is what we understood GloVe as, right? This much part is clear. Right?
Yes.
It is only taking the neighborhood, and based on the neighborhood, it is saying with this. But then, if it is able to remember, the first word was I, the next word was am, the third word was very, right? If it is able to remember this, then it forms when moment it remembers, it forms a context. Based on this context, it can try to say that in that because the previous word and the previous to previous word and the previous to previous word was like this, I think the next word should be like this. Anyway, what do you call? If it is possible for you guys, just brush up on your RNN knowledge, because what we will do next week is that we will not go by a simple neural network like this anymore. We will form a very complex neural network in which I will take advantage of this memory facility of RNNs and LSTMs, and we will try to see how we can apply that to language models so that it's able to predict things much better.
I'm completely new here. This is the first course I'm taking. So where do I refer for the RNN and LSTM?
Where do you refer for RNN and LSTM?
I do have it, but I'm not sure if I will be able to share it with you, Srividya.
Oh, okay.
Yeah, because it is in the IMK platform itself, nowhere else.
Okay, so do you have some time so that we can have a chat and you can possibly explain? I don't know.
Yeah, I mean, we'll work something together. Just send me your email address. We'll figure something out.
Yeah, sure.
Yeah, thanks.
You both can connect on LinkedIn. That's how I connected with Srividya.
Okay.
Actually,
Yeah.
she connected with me.
Yeah.
I was very grateful. Yeah.
Yeah, I did not. Yeah, Partha was a common. I think one of my friends attended a class from him in India. That's how I got connected.
Okay. So we see that we're able to teach the model. We teach them able to teach the machine a language, and using that learning, he's also able to try and complete sentences for me. So, do you think it is progress what we have done so far?
Yes, absolutely.
Yeah.
Okay. Now, the thing is that we already identified our problems, what we have. First problem, what we have is that if the word is not in his vocabulary, then he absolutely doesn't have a clue regarding what to do. So we have to solve that problem, right? We have to somehow make him understand words which is not in the vocabulary. That is one problem. Second problem, what we have is that, see, if we have words like this, begin, beginning, he doesn't understand that essentially they are the same word. He doesn't understand that. So these are morphologically the similar things. So I have to make him understand that these are basically the same word. Don't treat them as two different words, right? So I have to make him understand this. So that these two problems, and then we will try and see how we can make a better, because after the embeddings we have to make a sequence model. These RNNs, LSTMs, basically these are sequence models. So after we make the embeddings, we have to make a strong sequence model. Only when we have a strong sequence model, will we be able to, make a strong application. Yes, Aditi.
Partha, I also noticed that we did not do anything about the stop words in this. So is it not required in GloVe?
Not only in GloVe, actually in any language models, we do not do anything about the stop words. Okay.
But we did that for the other two items in the previous weeks, right?
No, right now, you notice that the pre-processing, if you even notice here also, I did minimum pre-processing, right? I want him to learn the language as purely as possible. So, right, as we move forward, you notice that the amount of pre-processing that we will do will be almost minimal, next to zero.
Got it. Yeah.
Okay. Think about it. Supposing I'm training ChatGPT, where it is training on huge corpuses, right? Complete Wikipedia, complete book 1, complete book 2, and all this kind of stuff. Do you think practically it is possible to do pre-processing on such a huge amount of corpus?
No, and also it is not desirable because we need to keep it as natural as possible as well, right?
Correct.
Yeah.
We need to keep it as natural as possible. So you notice that gradually as we're moving forward, we will do minimal pre-processing. Right? Okay, let me just summarize what we did so that it becomes. So let me clean the board. So today, PowerPoint seems to be performing better because we're not using its pen. Instead, I'm using it from Zoom. So, so this was where we did the hyperparameter setting. And after that, we calculate the distances, and this distances we took a log of these distances, and we try to minimize the loss. So this was the forward pass of the neural network. You notice here we have Wi, Wj taken at random and Bi, Bj taken at random, and then I find the dot product between Wi and Wj, add it to the biases, and then I get the target, that is log of Xij. Residual is taken, and then I get the loss, which I'll try to minimize in my total neural network. So then on training, we found that we were able to minimize the loss. And after that, we got our embeddings, and the embeddings, when planted on a three-dimensional graph, it showed some kind of pattern. right? This cannot be taken as what you call ended, because the corpus was very small, but in spite of that, it is able to find some patterns in that. But then when we took the Jane Austen's corpus, we found that it is able to find patterns, like it is able to what do you call we found that, right? You have seen this. Do you agree?
Yes, Partha, but I just also noticed that it is also kind of identifying between male and female names separately.
Yeah. So it is able to notice those kind of things. But important thing, did we give any such knowledge to the machine while it was training itself?
No.
It is doing it completely by the mathematics which we have taught him, right?
Yeah.
This much part you guys are convinced, right? That is, machine actually it has got no intelligence. It is just understanding the mathematics and applying the mathematics whatever we're teaching him effectively. So if we can develop the right mathematics, we can teach the machine effectively. If we cannot develop the mathematics, the machine will be as foolish as anything else, right? This much part, I think, whatever, I know many of you are very new to this machine learning part, but at least this much part, if you're having in your firm in your head, I think I have done a reasonable job. So with you guys, right?
Yeah.
Okay. So then we are able to make these clusters of words, and these are able to have meaning together. We saw that these kind of things, these patterns we have seen in the program what we have written. So the machine could effectively learn all these kind of things. So this is important. The meaning is inferred, not defined. So we didn't define anything. It inferred based on the logic what we implemented. It inferred the meaning by himself. That is most important thing. And after it has done that, so like I told you, the problem, like if it finds a word which is not seen at all, then it has got a major problem, which we will try to solve in the next class. When which this problem was solved by Facebook, and we will discuss the Facebook way of making embeddings in the next class. Okay. Okay. So that's it I have from for today. I hope it was interesting and useful, but I know it was little obtuse because some of you have what do you call little less exposure to neural networks. So if it is possible for you by any way, like you can read some books, or you can do some amount of video, you can check on YouTube to understand what are neural networks. It will really help, because LLMs basically depend on transformers. Transformers nothing but neural networks. Okay.